Right. Hi, everyone, and welcome to this YouTube Live. I'm hoping that you can hear me okay. Perhaps just say hello or something like that in the chat just to let me know that you're online and this has started satisfactorily. Hi, everyone. Just waiting for a comment or two in the chat to tell me that all is well and to tell me that you're online with me. Hello, folks. Welcome to this YouTube Live. I'm hoping that you can hear me and that you're all attached and ready to go. Okay, good. It looks like we're online and we'll be starting in a few minutes. I'm just going to share my screen now so you can see what we're going to be looking at during this YouTube Live. Thank you very much to those of you who have sent questions in. We've got a number of questions to go through this afternoon on a number of different topics, many of which are forecasted, predicted to come up in your paper on Monday. So I'm hoping you can see a question on the screen there. It's a very easy question to start off with, involving a straight line drawn on a grid. So thank you very much for your highs and your comments in the comment box. I'm assuming you can see the screen. Okay. Sally says no, that the screen can't be seen. Hello from the Gaza Strip. Can't see the question. Stop sharing, and I'll try and share it again. See if that does the trick. Okay. Right. Just tried to share again. Let's see if that means that you can see the screen. Right. Can you see the screen? The last comment I have, still no. It's gone black again. Right. Well, why is it doing that? Let me try again. Right. Okay, I'm going to stop sharing. Come back to here. This is exactly what I did last time, so it should be absolutely fine. Share screen. Choose the right window. Press share. All I've got is a black screen on my second monitor. Marvelous. Let's try stopping sharing again. Okay, let's try. One more time. Okay, this isn't going to plan. Still no. No, I can see that because I've got a second monitor here and the screen has just gone black. Okay. Right, let me try and close down my OneNote and open it up again. Right, I'm just trying to restart my OneNote. With any luck, then I'll be able to share the screen successfully. In the meantime, can I explain the conditions for upper and lower bounds? Well, I'll try to, but at the moment, I'm just trying to get my computer to function as it should. Right. Okay, so I've reopened OneNote. Let's try again. Okay. Right, hold your breath. Will this come up? Okay, so my screen has gone black again, my second monitor, and it's not showing the OneNote window. I'm open to ideas. What I'm doing is I'm simply going to the Share Screen tab and choosing the right window. Let me see if writing on the window makes any difference, makes it reappear. What have you said? Maybe disconnect the second monitor. The second monitor is just another, it's just a separate machine. So I don't think that's going to make any difference, but thank you for the thought. Maybe restart the whole YouTube live. So if I did that, would you find your way back to it? Right. Okay, so could correct suggestions in a Word document and write over it using the drawing tool. Yeah, but I'm not sure it'll let me share Word either. Let me have a look. So I'll just open the document. Ah, look at that. Can you see the screen now? Can you see you can see, brilliant, but it's just gone away again, hasn't it? But I have a horrible feeling it's now just gone. So let me try and reopen, reshare. Let's try. Reshare, window. Right. Okay. Yeah, I know you had it, but you lost it. But I have a feeling that I can sort that now because it seemed to come. There it is. There it is. Right. Are you happy? Can you see the screen? Right. Okay. So, welcome to this session, which is starting 10 minutes later than it was supposed to. I've got a whole load of different questions from you, so thank you very much. We're going to start off at an easier end of the spectrum, okay? And here is a very straightforward question. You're simply being asked to write down the equation of the line. So grab a pen and piece of paper and a calculator. And if I count to 10, then in that time, you should be able to write down the equation of that line, I hope. Now, if I was doing this one, I would be thinking about the y-intercept there, which is at 4, and I'd be thinking about the gradient. So in this case, the line is simply going to be y equals minus 2x plus 4. Minus 2x because the gradient is minus 2, and plus 4 because that is the y-intercept. How long is the live for? We'll see how we get on. You can come and go as you like, but I've got at least an hour's worth of questions here, from easy to much more difficult. Right, now question 10, which is on the screen now, is a question involving linear inequalities, and this topic is forecast to come up, so I will be quiet for a moment or two and leave you to work out how you would find the region defined by those three inequalities. Obviously, you can just sketch the graph and have a go at completing the question. Now, it tells me the equation of the line L, and it tells me the equation of the line M. Show by shading on the grid the region defined by all three inequalities. Right, well, L has the equation y equals a half x plus 3, and I've got y as less than a half x plus 3, so I'm going to be shading beneath L. Right, M has the equation y equals 2x plus 3, but I need to shade y is greater than 2x plus 3. So I'm going to shade to the left of M, or above M. Now I've got a third inequality here. X plus y is greater than 4. So I'm going to need to draw the line x plus y equals 4. So that's going to go through 4, 0 and 0, 4, or 0, 4 and 4, 0. So I'm going to draw that line now in green. And the inequality I need is that x plus y must be greater than 4. So I'm going to shade above that green line. So the region that I'm going to shade and label R is this region here. And please remember to label it R, otherwise you lose a mark for a foolish reason. Okay, that is number 10. Quite a straightforward start. 2 questions there. One on y equals mx plus c, and one on solving linear inequalities. Right, we are moving on to nonlinear now. Okay, working with nonlinear graphs. Let's have a look at question 7 here, which was sent in by one of you. Question 7 is all about translating a graph, or transforming a graph. Have a look at number 7, and then we'll make it a little more difficult so that we can just revise a few more concepts. Right, in question 7, you're given the graph of an initial function, which has a minimum there at -3, 0. And you're told that that function is translated, and that the new minimum is down here at 3 minus 2. So what's happened to that graph essentially is that it has been moved 2 units down the y-axis. So what used to be y equals f of x is now going to be y of f of x minus 2. Each of the points has been moved down 2, so your y coordinate is going to be 2 lower for each one. Now, while we're here, I'm assuming or hoping that if instead they asked you to write down the equation of the translated curve, and this was the translated curve, this one here, not very expertly drawn, there you are, draw it again, this one here, where that is 5, the point 5, 0, would you be able to write down the equation of the translated curve if they had asked you to write down the equation of this curve here? Have a go at that one. In this case, the curve is moved 8 units to the right. Now, if a curve moves 8 units to the right, then it's no longer y equals f of x, but it's now y is f of x minus 8. Okay. And similarly, if the curve had moved 8 units to the left, it would now be y equals f of x plus 8. And I'm hoping that that is simply revision of what you've covered before. All right, I'm keeping half an eye on the comments, but nobody seems to be complaining. So I'm going to move on to question 21 here. Again, thank you for sending this in. Whomever sent this one in. Not a straightforward part C, but an approachable part A and B, I think. So have a look at 21A, B, and C, and I'll just be quiet for a couple of minutes. Why was it minus 8? Let's have a look. Well, it was minus 8 because I made up the question, and it was moving 8 to the right. And so you go the wrong way. So you add a minus 8 into the function instead of, you have x minus 8 in the function instead of x. And yeah, you're quite right. The answer to the question which was asked was, why is f of x minus 2? That's correct. Okay, we're on question 21. And we've got a curve which has got this equation here. F of x is 9 minus 3 lots of x plus 2 squared. F of x is 9, oh, it's 9 minus something, isn't it? 9 minus 3 lots of x plus 2 squared. Now I'm asked to find the coordinates of A, and A is the maximum point. Now the thing is, because this f of x is given to you in the form of 9 minus 3 lots of x plus 2 squared, has completed the square there, but you know very well that x plus 2 squared is always positive. Okay, and we're subtracting 3 lots of x minus 2 squared, so we're subtracting a positive number from 9 to give us the value of f of x. You want f of x to be as high as possible, so you want to subtract as little as you can from 9. So you really want this value, the value of that blue shaded expression, to be 0, so that f of x can be as high as possible, subtracting as little as possible. So that means that your maximum point is going to occur when 3 lots of x plus 2 squared equals 0. Well, that's going to happen when x is minus 2, because x is minus 2 makes x plus 2 equals 0, and therefore makes 3 lots of x plus 2 squared equals 0. So our maximum point is going to occur when x is minus 2. And when x is minus 2, what value will f of x have? Well, f of x is 9 minus something, and we've decided that something will be 0. So the value of f of x will be 9. Okay? We're not finding the turning point here, really. I suppose we could be, but we're certainly not using differentiation to do that. We're simply reading off the maximum value from the equation for f of x, which is given to us in completed the square form. So my maximum is at the point minus 2, 9. Now, the curve C has this equation. F of x is 9 minus 3 lots of x plus 2 squared. And we're told that it's transformed to the curve S. And how is it transformed? Well, it's transformed by this vector 4, 0, which essentially means that the curve is shifted 4 units to the right. Now, if we shift a curve 4 units to the right, then the new equation is just as it was before, except instead of that x, we're going to have x minus 4. and then we have the remainder. So that is what the new equation of the curve looks like. I've simply substituted x minus 4 in place of x because the curve has shifted 4 to the right. Now, you could leave your answer like that, or you could simplify it and say f of x will be 9 minus 3 lots of x minus 2 squared, if you wanted to, but you'd get your mark for the unsimplified version there. Okay, now it's tricky, this moving curves left and right and up and down, but if you move a curve 4 to the right, then what was x becomes x minus 4. You substitute x minus 4 into the equation because if, for instance, you had this curve and this red curve here, if that's a shift of 4, then the green curve might be f of x, and therefore the red curve would be f of x minus 4. That's simply the rules for moving a curve to the right. Okay, all right. Okay. Now, you thought that was tricky. Have a look at part C. In part C, we've got the curve C, which was f of x equals 9 minus x minus 2 squared, equals 3 lots of, let me just copy it down right, c x plus 2 squared. And we are transforming it to the new curve, which has this equation. Here's the new curve. I'll put it in blue. It's being transformed to curve T, and curve T is 3 lots of x plus 2 squared plus 9. And you're asked to fully describe the transformation that maps C onto T. Okay? Now, this is probably the trickiest question we're going to look at today. Okay? I'm going to draw a set of axes. Meanwhile, of course, you might be doing this question ahead of me. Now, the red line is the curve which is f of x is 9 minus that quadratic expression. So that is the red curve there. Okay, that is the value of 9 on the y-axis. Okay. In fact, I've drawn that in the wrong place, haven't I? Because it should have a minimum when x is minus 2. So it should look like that. Okay. Now, what will the blue curve look like? Well, the blue curve is 9, but instead of subtracting the value of the quadratic, we're adding the value of the quadratic. So the blue curve will look like that. And so what is the transformation that maps curve C, the red curve, onto curve T, the blue curve? The answer is that it's a reflection in the line y equals 9. But I have to say to you that I don't think that many of the candidates would get that question right. I think that's a really very demanding question. And the reason and it is very demanding, which is the reason really why it's only been given 1 mark. Look. Okay. All right. Okay. Now, in answer to your question, Charlie, I have been sent a question like that, yes, where you have to manipulate an equation to solve the equation using a graph. There's one of those coming up. Okay. Right. Here's a question which will look familiar to many of you, and many of you asked me to look at trigonometric graphs and transforming those. So here's a question to have a think about. I will just draw the standard sine curve next to it for you. Okay. Now, when you're asked to find the value here of A and B, it's really asking you what has happened to that sine curve to transform it into the graph that we're looking at in the question. Okay. Now, first thing to look at is the range of the graph. Ordinarily, your sine curve has a range there of 2 because it goes from 1 to -1. So ordinarily, the sine curve has a range of 2. In this case, the sine curve has a range of, well, it has a range from -2.5 to +3.5. So the range of this curve here isn't 2, but it's 6. Okay. Now that would imply that we have got y equals 3 times sine x here. Okay, because the range is 3 times the size it was. Now, if I go to the right-hand side, if I were to draw that curve, y equals 3 sine of x, then it would look like this. It would come up to here, still go down through 0 there. It would be like that. So I'm almost where I want to be. My blue curve is almost like the black, but I notice that my black curve does not go through 0, 0. So what I'm going to need to do is I'm going to need to lift my curve by half. So the black curve is going to have the equation y equals 3 sine x plus a half. And the answer to the question is that a is 3 and b is a half. And well done if you got that. Now you can see that this is a question 24. So this is a question which the examiners consider to be tricky, to say the least. And again, another sign that they consider it to be tricky is it's worth only 2 marks. So somebody who finds that tricky is only going to miss out on a maximum of 2 marks out of the 100 marks on the paper. Okay. Now, here is a question which involves using a nonlinear graph to solve an equation. Now, it's quite difficult to read, so I will just write here that that is y equals x cubed minus 3x squared plus 5 there. Okay, and you're asked just to complete the table of values and hence finish the graph. So I'll let you have a go at that one now, and I'll be quiet for a second. Okay, now, the person who says that I don't understand any of this and the exam is next week, am I cooked? I see what you mean. However, remember that we've just been looking at one topic, and that's transforming graphs. If transforming graphs comes up, perhaps there'll be 4 or 5 marks for it, still leaving you with 95 marks on the rest of the paper. Okay, so the fact that you are having trouble with one particular topic, which is at the harder end, isn't a reason for you to panic. Okay? And in answer to the same person, to your question, I always skip the last pages because they're too hard. Well, you might find you can pick up a few part marks, but you also have to remember that generally speaking, to get a 7, you're looking for about 50% on both papers. So you can afford to skip the last questions if you're looking for a grade 5, 6. Or a 7, you could get a 7 by missing out the last quarter of the paper. But of course, any part marks you can pick up are really important, okay? Right, okay, I'm hoping that most of you have filled in. I'm not going to speculate on grade boundaries. I'm going to concentrate on these questions now. I'm hoping that most of you have filled in this table of values here, okay, by substituting x into that quadratic expression. So the answers I get here are when x is 2, I get a y value of 1. When x is 3, I get a y value of 5. And when x is 4, I get a y value of 21. Okay, so now I'm going to complete the graph. Now, be careful. Look at the scale. They often do this to you. They often have a different scale on the x-axis than they do on the y. They're just trying to trick you. Don't fall for it. Okay. When x is 2, y is 1. So that's going to be there, 2 little squares up. When x is 3, y is 5. And when x is 4, y is 21. Okay, and now I'm going to complete the curve in a smooth motion. Right, not bad? Right, okay, so I have completed the table and I've completed the curve. Now, this is what the question says here. I know it's not very legible, so I'll write it down here. Part C, use the graph to find an estimate for the solution to this equation. X cubed minus 3x squared plus 5 equals 0. So the question is, for part C, use your curve to find an estimate for the solution to that equation. Incidentally, it says the solution singular, so there's a clue. Now, the way to tackle this is you need to have one equation, which is y equals the left-hand side, one graph drawn. We've already drawn that one, y equals the left-hand side. And you need another graph drawn, which is going to be y equals the right-hand side, y equals 0. So we can draw the line y equals 0, and then we simply read off the x-coordinates of the points where our two lines cross. That's the line y equals 0. So we read off the x-coordinate of the point where they cross, and it looks to me as if it's about minus 1.1 or minus 1.2. But it's tricky to see. But it's the x-coordinate of this point here where the two lines cross. Now, before we move on, let's just make sure we're clear on what's going on here, because it's going to get a bit more difficult in a second. Let's imagine an extra question where we're asked to use the graph to solve this equation. X squared minus 3x squared plus 5 equals 2.5. Right, again, we're going to draw two lines. One of the lines is y equals the left-hand side of our equation. That's the line we've already got drawn. And the other line we're going to draw is y equals the right-hand side of our equation. Y equals 2.5. So we can draw the line y equals 2.5, and then we're going to read off the x-coordinates of the points where our two lines cross. That there is the line y equals 2.5. and I see it crosses in 3 places. So there are going to be 3 solutions to this equation. This is an equation I've made up, of course, and the 3 solutions are going to be the x-coordinates of the points of intersection. Okay. Right, so what you've just had there is a crash course in using graphs to solve equations, but we haven't done a tricky one yet, because on both the ones we've done, the left-hand side of the equation is the same as the graph that we drew. In the last part of this question, you're asked to solve this equation here. The equation you're asked to solve is x cubed minus 3x squared plus 2x plus 4 equals 0. You're asked to solve the equation x cubed minus 2x squared plus 2x plus 4 equals 0. And the tricky thing is, if I say to you, draw y equals the left-hand side and y equals the right-hand side, well, the graph we've drawn isn't going to help us, because the graph we've drawn is not y equals the left-hand side, which is why this question is difficult. What we've got to do is we've got to take the equation they've given us, and we have to rearrange it, doing the same to left and right, so that it becomes an equation with the expression we want on the right-hand side. The expression we want on the right-hand side is the graph we've drawn. So we are going to rearrange algebraically the equation they've given us, which is this equation, which I put a yellow blob next to. We're going to do the same to left and right on that equation, so that we have this blue expression on the left. Why are we doing that? Because we've already drawn the graph y equals the blue expression. Okay, and I can see that some of you are onto it already. So what I'm going to do to both sides of the top equation there is, I've got the right x cubed in there, I've got minus 3x squared, that's good. I see there's plus 2x at the top. I don't want those, so I'm going to minus 2x from both sides. And then I'd have a plus 4, wouldn't I? And I don't want a plus 4, I want a plus 5, so I'm going to add 1 to both sides as well. So that means that my new equation will be this one. X cubed minus 3x squared plus 5, because that's what I'd had on the left, and on the right, I'd take away 2x and add 1. Aha! Now I've rearranged the equation they've given me into an equation I can solve. And I can solve this equation because I can plot y equals the left, which is y equals x cubed minus 3x plus 5. I've already plotted that. And I can plot y equals the right, y equals minus 2x plus 1. And then I can find the points of intersection. How do I plot y equals 2x plus 1? Well, I use gradient and intercept, but I'm really careful because of the scales. So plus 1, that's going to be 2 little squares up, and a gradient of minus 2. So I'm going to go along 1 and down 2. Along 1 and down 2 on this ridiculous scale. Okay, so it's going to be tricky. So I'm going to go along 1 to the left and up 2, and along again and up 2. So my line is going to look something like this. Oops, beg your pardon, try again. It's going to look something like that, okay? And then I'm going to read off the x-coordinate of the point of intersection. Okay? All right. That is the end of that question, and many of you asked for an example of using a graph to solve an equation. So we've done 3 equations. We've solved 3 equations using that graph. Okay, right. Okay, I'm moving on. All right, and we have got just one polygon question to do now. So thank you whoever sent this one in. Okay, have a quick go at this polygon question, which is a question 11 from a past paper. darker colour. Right, I'll do my best. I'll go to black. Okay, I'm thinking that that's probably better. For cumulative frequency, I personally would draw a smooth curve. Okay. I don't think it's wrong if you connect each separate point with a ruler when you're drawing cumulative frequency, and then you end up with a sort of with a curve which is just a series of straight lines. But I would just use a smooth curve because that's the same as I do for everything else. No, you won't lose marks. You won't lose marks. You just need to do the best you can. It might look something like that. Okay, and if I can do it on a screen, then you can do it on you can do it on your paper. But if it is cumulative frequency, you are allowed to. It's not wrong if you had this and you had the points like this. Okay, it wouldn't be wrong to use a ruler to join each one up, each part of it up, but you'd have to draw lots of separate straight lines, which obviously isn't a problem. Okay, so that would be allowed in a cumulative frequency question. Okay, right. Okay, we're looking at this polygon question now, I think. The diagram shows a regular pentagon and a regular hexagon. Right, I'm inclined just to wait for 30 seconds to give you a chance to do it. Right, now what do I know about pentagons and hexagons? Well, the pentagon has 5 sides, and its exterior angle is 360 over 5, 72, and its interior angle is 180 minus 72, 108. Oh, so that means that this is 108, look. Okay, what do I know about a hexagon? Well, I know that its exterior angle is 360 over 6, and so its interior angle is 180 minus 60, 120. Okay, now I'm thinking that I can find this angle here by doing 360 minus 120 minus 108. So that means that angle what is it? BAJ, isn't it? Angle BAJ will be 360 minus 120 minus 108. Well, that's 132. Okay, now how can I find x? Oh, do I know that's an isosceles triangle? Do I know that BA is the same as AJ? The answer is you do, because you know that these two sides, which I'm shading in blue, are equal, and you know each of the shapes are regular, so each of them have got all equal sides, so you know that's an isosceles triangle. So that means that x is going to be 180, subtract the angle at the top, 132, and then divide by 2. So x is equal to 24 degrees. Okay. All right. Okay, right. All right, so I'm moving on, I think. It's not a race, you lot in the comments, to get the answers, okay? All right, I'm going to go deliberately at quite a steady pace, so with any luck, most people can keep track. I agree, it's quite straightforward. Okay, now, we've got 2 questions here involving right-angled triangles. There's one question, which again, I think is quite straightforward, but nonetheless, thank you for sending it in, whomever did. And then we've got another question, which involves 3D trig. Okay, so first of all, question 10. I'll be quiet for a moment. If I was drawing a tangent at any point on a curve, I think I'd just use a ruler and sort of do my best. Okay. 180. I'm not sure that's the answer. Oh, is that the answer for the perimeter? I'm not sure that's right. Let's have a look. Okay. So we know it's an isosceles triangle, and we know it's got a base of 24. Look, we know the perimeter is 54. So I think that's going to enable me to find this yellow side length there. So I've got 54 for the whole perimeter. Take away the base. That leaves me with 30 centimetres left for the perimeter. So I'll divide that into 2 because I've got 2 more sides remaining. So that side is 15. Brilliant. Okay, so I've got to work out the area of this triangle. And I'm going to need to know the height, aren't I? So I need to know the height of the triangle. So how do I work out that height? Well, the answer is I use Pythagoras, but don't get it wrong. Remember that you've got that red height, which I'll call h for height, and then you've got the base here. That's a right angle, that's 12, and the hypotenuse is 15. So now you can find h by using Pythagoras. H is going to be the square root of 15 squared minus 12 squared. So h is the square root of 225 minus 144. That's the square root of 81. So h is 9. Okay, so I know my height's 9. H is 9. So the area of the triangle is the base, 24. Make sure you use 24, not 12, times the height divided by 2. Half the base times the height, which gives me 108 for the area of that triangle. Okay, so there you are, quick using Pythagoras, finding right angle triangles in that isosceles. So now, a more difficult question. Okay, on 3D trig. So I'm going to pause for a second. You have a look at that and give it a go. The answer is I don't know whether paper 2 will be more difficult than paper 1. I would kind of just expect there to be the topics we're expecting to come out. There'll be some repeats of topics on paper 1, I'm sure, and I'd expect a range of questions from easy to hard, just as usual. Okay. Right, I'm still pausing while you have a look at number 9. Somebody said, what topic can I search up to practice those questions at the start involving maximum points, cosine graphs? That's transforming graphs. Okay, annoyingly, there isn't a film on my channel on transforming graphs. We're expecting vectors, yes, and we're expecting coordinate geometry. Of course, we don't know, but we do know that those didn't come up on the first paper, or on 1H anyway. Vectors didn't come up on 1HR either, I don't think. Coordinate geometry is gradients, finding the equations of lines when you know the gradient and the point, finding the equations of perpendicular bisectors, that sort of thing. Okay. Fatima, I can't remember what the question you sent in was about, but I think I've included it. Okay. Right, I'm going to have a look at this number 9 now. 3D trig we're expecting to come up, and this is a question on 3D trig. Now, it asks you to find the angle between TB and the base. Now, the first thing to do is to draw that line TB, and then the difficulty is where do you draw the line at the bottom? You know, where is this angle from? I know it's from TB, but then what do I do? Do I draw this line at A or at D or what? And the answer is you go vertically below T. You imagine the shadow of T if the sun were out, and that angle there, the angle alpha, is the angle that we're trying to find. Now, I'm going to find that by considering the right-angled triangle that alpha's a part of. And that right-angled triangle goes from T to M, and then across the base to B. So that is alpha there. Okay, that's a right angle. Now I'm thinking if I could find a couple of sides on that triangle, then I could use trigonometry to find the angle alpha. And the first side that I'm wondering about is MB, the side MB, because I can see that MB is on the base of the shape. And if I have a think about the base of the shape, I could go M to A and across to B. And that right angled triangle, which I've drawn in blue, so I hope you can see it, is a right angled triangle that is horizontal on the base of the shape. It's got a length of 10 from A to B. Now M to A is 3.5 because it's half of 7. And now I can use trigonometry to find MB. MB will be the square root of 3.5 squared plus 10 squared. So I can now find MB. Using my calculator there, I get an answer of 10.59 for MB. So now I know that MB up here is 10.59. Good. Now I really want to find TM now. Okay. Should I be slowing down, May? Am I going too quick? I'm going to find TM. No. To find TM, oh, TM is given to me. It's 6. So now I can use trigonometry on this red triangle at the top. I've got tan alpha, and that's going to be the opposite, 6 over the adjacent, 10.29. There you go. So I can use my calculator, and I can go 6 divided by 10.29 equals, and then shift tan equals, and I get my answer for alpha of 30. Do I? No, I don't. I pressed the wrong button. Try again. 6 divided by 10.2. It's 10.59. Sorry. There you go. I've slowed down now because I keep on making mistakes. So 6 divided by 10.59, shift tan equals, and I get the answer 29.53 and so on. So to one decimal place, it's 29.5. Okay, thank you very much. You were ahead of me in the comments. Oh, including you, May, so I can't have been going too quick then. Right, that's number 9, and that's an example of 3D trig. Okay, right, we are going on now. Can we round before our final answer? I wouldn't round too early, which is why I kept that 0.59 here. Perhaps I could have included a few more decimal places, and then I used 10.59 in there. I didn't use the whole answer. Okay, but I had an extra decimal place, so I thought I'd be all right. Okay. All right. So you left it in third form. Let's just have a look at the question here. Whoever left it in third form, it says give your answer to one decimal place. So don't leave it in third form. If it asks for an exact answer, then that's a clue that you'd leave it in third form. Okay. Right, we are moving on to simultaneous equations. We're expecting questions on linear simultaneous equations, I think, and on quadratic simultaneous equations. Here's an example where one of the equations is quadratic. Okay, so I'll be quiet to give you a chance to work your way through that, or at least make a start on it. Yeah, you could keep it in third form halfway through your work. That's probably much better than what I did. Okay. Fatima, can you just remind me what your question was about? Because then I'll remember if I've got the topic in here or not. Most of these topics will come up, well, they could come up on either paper. Sorry, let me rephrase that. Is this for, yes, Fatima, you'll just have to tell me so that I can remember. I'm not going to look at my email now. Is this for paper 2HR or for 2H? Well, all of these questions and topics could come up in paper 2H or paper 2HR. You'll have seen the prediction films, and there's quite a lot which could come up in either paper, of course. Okay. So there's nothing, no reason not to be here if you're doing 2HR, and no reason not to be here if you're doing 2H. It's good to see the ginger mathematician with us. Okay. The reason that I'm doing this live, oh ginger mathematician, is because you suggested I did. So you are responsible. Right. Let's have a look at the email then, Fatima. I've done that question already, the first question, Fatima. You've already done that question. So I'm feeling like I've done what you asked me. Okay. Right. So this is a question here where one of the equations is quadratic. So what I would do is I would use one of the equations to give me an expression for x or an expression for y, and I substitute that expression into the second equation. In this case, you're already given an expression for y. You're told that y is 7 minus 2x. So what you have to do is to substitute that expression for y into the second equation. Now the second equation is x squared plus y squared equals 34. So x squared, now instead of y squared, I'm going to write 7 minus 2x squared. Because y, after all, is 7 minus 2x. And that equals 34. Now, the secret now is to solve this equation for x without messing up your algebra. Okay? So, x squared plus, now because I'm going to do this slowly and carefully without messing up my algebra, I'm going to write 7 minus 2x squared as 7 minus 2x lots of 7 minus 2x. And now I'm going to multiply out those brackets. 7 sevens are 49, minus 14x, minus 14x. Now minus 2x times minus 2x plus 4x squared equals 34. So I'm just taking it slow and steady. You've got lots of time to do these questions in your exam. Okay, just don't mess it up if you can help it. So that gives me 5x squared minus 28x plus 49 equals 34. So now I'm going to subtract 34 from both sides so that I've set my expression equal to 0. Okay, I've got a quadratic equation to solve for x. Now, you could use the formula. Of course you can. In this case, it doesn't say give your answer correct to 3 significant figures or 1 decimal place or anything like that, which is a kind of hint that you'll probably be able to factorize it. But if you're somebody who feels confident using the formula, use the formula. Don't think about it. I'm going to factorize it. Okay, x and x. Now I know that both my signs are negative because I've got a plus 15 there and a minus 28x. Okay, and I'm going to do 5 and 3 there because that gives me minus 25x's and minus 3x's, gives me minus 28x's. But, you know, I've been able to factorize it off the top of my head, really, but there's no reason why you should have to do that. You can just as easily use the formula. If you do use the formula, you should get the same answers as me, of course. X is 5 or x is equal to 3/5. Now, how to get y? Well, the answer is use the equation y equals 7 minus 2x. Okay, yes, you do definitely lose marks if you put the quadratic into your calculator because it says show clear algebraic working. So do not do that. Okay, right. X is 5, then y is, wait a minute, I might have been doing you an injustice there. I think you probably meant just by solving the quadratic by putting it into the calculator. Okay, that being the case, if you meant that, then you'll probably be all right. But I would definitely write x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, and then show you know what a is, b is, and c before you start using your calculator. Okay, back to this. If x is 5, then y is minus 3. Or alternatively, if x is 3/5, then y is 7 minus twice 3/5, which is 7 minus 6/5, which is 5 and 4/5. So that gives me the solution 3/5, comma 5.8, or 5 and 4/5. So there are my two solutions. I'm going to just leave that on the screen for a minute while I look at your comments. Okay. Why 3/5 and not just 3? Well, the 3/5 and not just 3 comes from here. It comes from 5x minus 3, lots of x minus 5 equals 0. And you might remember when you're working out the answers for this, you say to yourself, okay, what value of x makes x minus 5 equals 0? X minus 5 equals 0. Oh, well, x must be 5. And then you say to yourself, okay, what value of x makes 5x minus 3 equals 0? 5x minus 3 equals 0, and you solve this equation. Okay, so hence I got 3/5. Okay, right, y 3/5 2. Now, do we write our answers as coordinates, or do we write the x values and the y values under each other? Now, the answer is that in this question, it doesn't matter whether you write them as coordinates or whether you write x equals this and y equals that. But what you've got to show is that you appreciate that this is one answer. The x is 5 and the y is minus 3. They go together. That's one answer. So you could do x equals 5, y is minus 3, but then put them in a box. And then say x is 3/5 and y is 5.8, and put them in another box. Show that you know that actually this is 2 answers, not 4 answers. Okay? All right. So that is a good example of a question, simultaneous equations when one is quadratic. I'm tempted to move on. All right. Let's look at proportion. Right, here's a proportion question for you to look at. Okay. Will we practice the linear one? We can do a linear one, May. Just remind me towards the end and I'll just stick one on the screen, okay? All right. So, proportion we're on. This is a particularly tricky proportion question. I'm not sure, you two, that quadratic simultaneous equations appeared in 1HR. Okay, I'm going to have a look at question 20 in a minute or two. So get yourself to a stage where you've either got an answer or you've tried to solve it and you've got as far as you can. Generally, these questions are easier than this. And if you had a question 20, it would probably be worth about 4 or 5 marks, and you'd get decent part marks for doing the easy bits at the beginning. Okay. Now, I hate to say it, but I think that answer 4.21875 is not correct, but it is at least exact, I'm guessing. I'm guessing that that wasn't a decimal that went on forever. Okay, let's have a look. Now, in blue then, y is inversely proportional to root of x. So y is proportional to 1 over the root of x. Y equals k over root x. We're probably used to doing that. Now, from the second piece of information, which is shaded in red there, x is proportional to t cubed. So x equals, now I'm not going to use k again, all right? So I'll use m. X equals m times t cubed. So I've got two expressions here. I've got y equals k over root x, and I've got x equals mt cubed. Okay, so I'm going to get this expression mt cubed, because that's what x is, and I'm going to put it into here in place of the x. So y is going to be k over the square root of mt cubed. Right. Now, here's a formula here in blue that links together y and t cubed. K and m, they're just numbers, right? Okay, they're just numbers. So I'm just going to write this as y equals n over root t cubed. What I'm doing really is I'm saying, yes, I know that y is k over root m times by 1 over root t cubed. And I'm just going to call k over root m, I'm just going to call it n. I just can't be doing with k and m, just call it another number, because k and m are both numbers. Right, so now I have a formula that links together y and t. My formula is that y is n over root t cubed. I now have a piece of information. Here's my information. Y is 8 when t is 25. Oh, okay. Y is 8. 8 equals n over the square root of 25 cubed. Okay? So I can find n now. N is going to be 8 times the square root of 25 cubed. Well, that happens to be 1,000. So now I know the formula that links y and t. Y is 1,000 over the square root of t cubed. Okay. Right, now what does the question ask me? Find the exact value of t when y is 27. Okay, 27 equals 1,000 over the square root of t cubed. And I've got to find t. So I'm just going to solve this equation. Multiply both sides by the square root of t cubed and divide both sides by 27. T cubed is 1,000 over 27. Okay, sorry, the square root of t cubed is 1,000 over 27. So t cubed is 1,000 over 27 squared. And t is the cube root of 1,000 over 27 squared, which is, on your calculator, 100 divided by 9. Okay, now I am not suggesting that that question is terribly easy. Okay, you'll be pleased to hear. But there would be many part marks that you could pick up there. Okay. Now, most proportion questions don't involve two variables, x and y. They simply have x is inversely proportional to something. Write down the formula, put in the numbers, use the formula. There are many easier ones. If we have a bit of time at the end, perhaps we'll pull out an easier one. Okay. Right. We need to move on, otherwise we'll be here all evening. Circle theorems. We've got two circle theorem questions. Thank you to those of you who sent them in. Here is the first one, number 14 on the left. Okay, there you are. You see, the minute there's a horrid topic, then an easier one comes along. So once you've worked out the size of angle DCB and given a reason, then you're asked to find the size of angle ADO. Yeah, this video, once we finish, will be on the channel. Yes, Fatima, though I might edit it and knock off the first 10 minutes while we were trying to share the screen. Right, DCB, this angle here, is indeed 140, and that is because opposite angles in a cyclic quadrilateral add to 180. Good. Okay. Now you're asked to find the size of angle ADO next. ADO. This angle here, which I'm shading in blue. All right. A couple of things going on here. I'm sure there are different ways to do it, but this is how I've done it. First of all, I know that the angle here at B, I know that that's the angle between a radius and a tangent, so I know the whole angle there is 90, which tells me that this angle here is 90 minus 66. Okay, which is what? 24. Okay, so that's 24. Now, this angle at the center is 80, double the 40 at the edge, which means that I can find the whole of that green angle there, 360 minus 80. 280 there. And then what I did was I looked at this quadrilateral here, which looks like an arrowhead, and I know that the interior angles of a quadrilateral are 360. So I did 360 minus the three angles that I know, 280, 40, and 24. 360 minus 280 minus 40 minus 24 gives me an answer of 16 for that target angle. Okay. All right, so the shape isn't symmetrical, I'm afraid, May. Okay. Now, Paul, when you say that's not a cyclic quadrilateral, if you're referring to the blue arrowhead, then you're right. But we use the cyclic quadrilateral for the first part of the question. We use the cyclic quadrilateral to find this angle here. And we had the 40 and that angle, and those are opposite angles in the cyclic quadrilateral. Okay. Fatima, in part one of the question can be solved using the angle twice the angle. I think if in part one you're saying, does finding that angle help? It might do. It just doesn't seem as easy as just doing it in one step. Right, I'm going to, I think if I press undo a few times, I'll be able to put the whole solution. There it is. There's the whole solution back for you. Okay. Right. Okay, I think I'm moving on. Now, the reason that I've chosen this question here is that it's a good reminder of the alternate segment theorem. So I've put a little picture there to remind you about the alternate segment theorem. Okay, and I'm going to be quiet for a moment while you look at number 20. Whenever I'm looking at the alternate segment theorem, I always imagine a windsurfer. That's the sea, that horizontal line, and then that's the sail of a windsurf. And for some reason, then it sorts it out for me. The trick with this question is to draw yourself a line from C to A. Okay. Now, if I draw the line from C to A, then I'm hoping that you can tell me what that angle there will be. All right. Now, the answer is, well, I'm just going to draw it out here. Just so that you can see. I'm just going to draw part of the diagram. I haven't drawn it terribly well, but never mind. Let's try again. There we go. Now, that angle, which is x, is the same as that angle because of the alternate segment theorem. So that red angle at the top is x. Now, you know you've got an isosceles triangle there, ABC, so you know that this angle as well is x. Okay? Right. I'm going to rub out that little bit there, and we're going to concentrate on this bottom bit here. This angle here is x and x, so that angle is 2x. And so now, using the alternate segment theorem, you know that that angle is 2x as well. And there you go, prove that CDA is 2x. I've done it. Okay. And that is question 20. Okay. I like it, those of you, that somebody in the comments has found this angle here as 180 minus 2x. That's very neat. And then used opposite angles in a cyclic quadrilateral to get that the angle at D is 2x. That's another way of doing it. I just used the alternate segment theorem twice. How do we know CAB is isosceles? Sorry, there's no need to apologize. It's marked as isosceles, though, in the question. You've got two little ticks there, which I've just highlighted in yellow to tell you those two sides are equal. Okay, then it's not because two radii are the same, because neither of those are radiuses, those lines, I'm afraid. Okay. Right. Okay. Now I wanted to show you this because I've come across a really good way of remembering the intersecting chord theorem. So very quickly, I'll make up a question and show you the intersecting chord theorem. We'll show you my sort of the way that I've now started to remember it. So you might wish to just jot this down. There's one chord. Here's another chord, which I'll do in blue. Okay, there it is. Okay, and I'll tell you for nothing that that's 6, that's 4, that's 3, and you're asked to find the length of x. Okay, right. So there is a vectors question coming up, but let's quickly do this. Now, if you know how to use the intersecting chord theorem, then you're quids and you've probably already worked this one out. If you don't know how to use the intersecting chord theorem, then here's my how-to method for you. First of all, call that chord AB and that chord CD. And it doesn't matter what you call the point in the middle. I'm going to call it P. Now, one of your chords must be called AB and the other one must be called CD. And then you do this. You write AB, CD in alphabetical order. Then you put a P after each one. P being the point of intersection. Then you write times, times, and equals. And there is your intersecting chord theorem. The secret is to do A, B, C, D in alphabetical order. And then you can just fill in your gaps. So AP is 6 times 4 equals 3 times x. So 24 equals 3x, x equals 8. Okay, and this method here works as well when the point of intersection is outside the circle, okay, which I really like too. So if your point of intersection was outside the circle like this, there's one chord, here's the other chord, you would still label this A, B, and this one C, D, and that the point P, and you can still write down the same formula. Okay, right, I'm moving on to vectors. And here is a really horrid vectors question. Okay, now, quite a lot of these vector questions work out more easily than this one, okay? But this one was sent in, so I thought I would do it. So I'm going to be quiet though for a couple of minutes, and you'll be pleased to hear after vectors, we've got some differentiation and some coordinate geometry, and then we're done. Okay? Can I zoom in a bit? Yes, of course I can. There you go. There's the question. Okay. Right. Okay, I'm going to be quiet for kind of 4 or 5 minutes, I guess, to let you get into this question. Okay. Okay. The first thing I'd be doing is I'd be labeling the diagram up with all the information. Okay. Now, AB is A, BC is B, DM is a half B. I've put that in. K is the point on AB, so that AK to AB is lambda to 1. So that tells me that AK is lambda AB. Maybe it's 2/3 of AB. I don't know, or 4/5 of AB. But anyway, that lambda is a fraction, right? And so AK is a certain fraction of AB. And similarly, I know that CL is mu of CD, a fraction of CD. I don't know what fraction it is. Okay, 3/5, something like that, perhaps 4/7, whatever. Now, I'm also told that the ratio of mu to lambda, of lambda to mu, is 1 to 2. So I know that mu is 2 lambda. Okay. So that means that CL, I might as well write that as 2 lambda of CD. Okay. So now I've got AK is lambda AB and CL is 2 lambda CD. All right. Well, I know AB, don't I? So when I've written here, AK is lambda AB, I might as well write AK is lambda of A. And in the same way, CL is, well, CD, what's CD? CD is minus A. So that's minus 2 lambda A. There we go. All right. So I've used the information in the question. I've used this information, that information. I've used that ratio. And now it tells us that Km is a straight line. Okay. Sorry, KLM is a straight line. Right. Let's have a think about KLM. Now, let's first of all find the vector from K to L. Right, if I was going from K to L, I would go KA, then AD, and then BL. Okay? Now, KA. I've worked out KA, because look, I've got AK, so KA is just minus lambda A. Now, A to D is just B. Now, D to L, not sure about D to L. I'll tell you what, let's work out D to L. D to L is going to be CD. Just a moment, no, it's not. D to L is going to be D to C, and then C to L. D to C is A, and then C to L is minus 2 lambda A. Okay, so that's DL. So now I'll carry on down here. A minus 2 lambda A. Many of you will be pleased that this live will be on the YouTube channel, so you can watch this again if you need to. All right, so now I'm simplifying this expression for KL. So I'm going to have A minus 3 lambda A, plus B, or A lots of 1 minus 3 lambda plus B. So there's an expression for KL. Okay? This isn't A-levels, why are we being tortured? Well, it's 5 marks out of 100, and it was the last mark on a paper, so it is truly horrid. Right, that's KL. Now, I'm going to find next the vector LM. Now, I've chosen the vector LM to find because I know that KLM is a straight line. So I know that each of these vectors will be multiples of the other. One vector will be the multiple of the other. So LM, let's do LM now. Well, LM is LD plus DM. Now, LD is just minus A. Okay, so I beg your pardon. Yes, it's just minus A. Is LD? Where's LD? I've lost it. L to D. Oh, sorry. L to D is minus A plus 2 lambda A. Okay, I have that here, look. All right, plus dm. D to m is half of a b. So that is a lots of 2 lambda minus 1 plus a half b. Right. I've got KL in terms of A and B, and I've got DL in terms of A and B. And I know that KLM is a straight line. Let me just say that again because I said it wrong. I've got KL in terms of A and B, and I've got, there's KL, and I've got LM in terms of A and B. And I know that K to L to M is a straight line. So I know that A lots of 1 minus 3 lambda plus B, which is my first vector, and the second vector, A lots of 2 lambda minus 1 plus a half B, I know that one is a multiple of the other. And look at this. I've got half a B here and a whole B here. So I know that this top vector must be double the bottom vector because the coefficient on the B is double. So the coefficient on the A must also be double. So that means that 1 minus 3 lambda must equal double 2 lambda minus 1. And now at last I've got an equation for lambda. 1 minus 3 lambda equals 4 lambda minus 2. 7 lambda equals 3. Lambda equals 3 over 7. So I've got lambda now. Now all I need is mu. Okay, so if I can zoom out a bit, then I can use, having got lambda, come on, let me zoom out. Right, how am I going to find mu? Must be staring me in the face. How do I find mu now? Oh, sorry, mu is 2 lambda, isn't it? Okay, so mu is simply 6/7 because mu was 2 lambda. Okay, now that is quite a complicated vectors question. I did my first YouTube live the other day, and this was the first question that was suggested, and I'm afraid I balked at doing it off the top of my head the day before yesterday, but there it is. There's the solution today. Okay. All right. May, you can't just say you're fine with being grade 7 just because this question was horrid. It's only 5 marks out of 100. You've still got another 95 marks on the paper. Right, we are moving on, otherwise we won't finish. Differentiation. Here is a question on kinematics, which I was asked to include. Okay, you'll be pleased to hear we've got this question and then one on coordinate geometry, and that is all the questions that I was going to do today. So have a go at number 17. I'm not sure about the question that I missed out on the IGCSE questions. Perhaps it was you who left a comment saying you put the question, but question 15 didn't match or something like that. I haven't looked into that yet, but I wasn't going to do a question on a cuboid today. We had this question, number 17, and then a question on coordinate geometry. And yes, you're going to need to differentiate because you need to find how distance changes with time, ds by dt, because that is velocity. Okay. Okay, so thanks for the comment on that film. I just haven't had time to do anything about it, I'm afraid. Now, we've got a formula for the displacement of P from O, and the formula is that the displacement is 4t squared plus 125 t to the power of minus 1. And I've written it as t to the power of minus 1 because that's going to make it easier to differentiate in a moment. Okay, so that is a formula for the displacement. So my formula for the velocity is going to be ds by dt. How does the displacement change as time changes? That's the definition of velocity. So I'm simply going to differentiate this expression here, which is going to give me 8t minus 125 over t to the power of minus 2. Remember that you do the power times the coefficient, then you knock one off the coefficient. Now I'm asked to work out the distance from P, as in the displacement, at the instance when velocity equals 0. So I've got an expression for the velocity here, 8t minus 125 over t squared, and I'm asked to find when that is 0. So I'm going to put that equal to 0 and solve that equation to work out after how many seconds the velocity is 0. If I was solving this equation, I think I'd write it as 8t equals 125 over t squared, and then I'd multiply left and right by t squared. So 8t cubed is 125. So t cubed is 125 over 8. Cube root that gives me a t of 5 over 2. So after 2.5 seconds, the velocity is 0. And I'm asked for the distance of P from O when the velocity is 0. So I'm going to get my distance formula. Here it is. And I'm simply going to substitute in there, t is 5 over 2. So the distance will be, S will be 4 times 5 over 2 squared plus 125 divided by 5 over 2. And that distance is, on my calculator, equal to 75. So there we go. Okay. So I used the formula for the displacement to get a formula for the velocity by differentiating. And then I knew I needed to set that equal to 0 because I was asked to work out the distance from P when the velocity was 0. So I set the velocity equal to 0, got the time, and then substituted that value of t into the formula for the distance. All right. That is an example of a kinematics question. All right, I'm going to move on to the last question we're going to look at. Question 22. First thing to do there is to draw a diagram. If in doubt, draw a diagram. Okay. So I'm drawing my diagram, and I'm just trying to write all the information that's given to me in the question on this diagram here. So I've got a right angle triangle. I've got an angle of 90 at B, coordinates of A, coordinates of B, coordinates of C. Okay. Now, I'm told here that the gradient of AC is -6/7. So that's going to be useful, and I put that in a yellow. I've highlighted that in yellow, so I'm going to do some work here underneath this yellow highlight to do with that fact. There is another fact here which I can use to generate a second equation, and that is that AB and BC are perpendicular. Okay, and so I'm going to highlight that in blue, and that's going to give me a second equation. So I'm going to use each of these two conditions, and each one is going to give me an equation in P and Q, and then I can solve the equations simultaneously. So the first thing I'm going to do some work on is that yellow fact, and the yellow fact is about the gradient of AC. So let's write down A here is P10, and C is 8, Q. So the gradient there is going to be 10 minus Q, the change in Y, over P minus 8, the change in X. And I know that that is -6/7. Okay. So I can multiply both sides of that by 7 to give me 70 minus 7Q, and also multiply both sides by P minus 8 to give me -6 lots of P minus 8. So now I've got 70 minus 7Q equals -6P plus 48. Okay, so I'm going to rearrange that. I'll have 7Q minus 6P there, and 22 on the left, 70 minus 48. Okay. All right, now it doesn't matter, in answer to your question, where to locate A, B, and C. Just draw them and write their coordinates next to them. Okay. All right. Now I'm just going to tidy this up here. So that is my first equation for Q and P. And that is generated from the fact that I know the gradient of AC. Right, my next equation I'm going to generate by the fact that I know that AB and BC are perpendicular. So I'm going to find the gradient of AB, and I'm going to find the gradient of BC. So let's do AB first. So the gradient of AB here will be 10 minus minus 5, 15, over P minus minus 1, P plus 1. So that's the gradient of AB. And I'm also going to find the gradient of BC. Right, B is -1 minus 5, and C is 10, is P comma 10. Right, so the gradient there is going to be what? Here we are. Wait a minute, I'm confused. I think I've made a mistake, right? I've written down the wrong coordinates for C. Sorry about that. B is -1 minus 5, and C is 8 comma Q. Right, now I can write down the gradient of the line BC. I'm going to have eight minus 1 is 9. Sorry, I'm having a bit of a nightmare here. What's gone wrong? I need to find the difference in the y's. So that's going to be q minus 5 is q plus 5, and 8 minus 1 is 9. That's better. Okay. Right. So there's my gradient of AB and my gradient of BC. Now I know that 1 is the negative reciprocal of the other. So I'm going to write 15 over p plus 1 is, let's flip the gradient of BC and put a minus sign in front of it. There we go. So there's my second equation with P and Q. Okay. So that's going to give me, multiply both sides by Q plus 5. 15 lots of Q plus 5 equals minus 9 lots of P plus 1, multiplying both sides by P plus 1. 15Q plus 75 equals minus 9p minus 9. So I get 15q plus 9p equals minus 84. Right, I've got two equations now for p and q. One of the equations is 7q minus 6p equals 22. And the other of the equations is 15q plus 9p equals minus 84. Okay. So I've just got to solve those equations simultaneously now. I'll just pause for a second and catch my breath while you make a start on those simultaneous equations. So what I would do, I think, is I'd get the coefficients of the p's, I'd deal with those. If I multiply this top equation by 3, then I get minus 18p. And if I multiply the bottom equation by 2, then I get plus 18p. So that's going to give me 3 times 7q, 21q minus 18p equals 66. And the bottom equation is going to be 30q minus 2 9s are 18, so plus 18p equals twice minus 84, it's minus 168. Right, I've got minus 18p and plus 18p, so I'm going to add my equations, which is going to give me 51q. Oh, somebody wanted to practice linear simultaneous equations, so here you are. Here's your practice. 51q equals minus 102. So q is minus 2. So now I simply have to find p. So let's use the first equation. Shall we? 7q minus 6p equals 22. So 7q, that's minus 14, minus 6p equals 22. Let's add 14 to both sides. Minus 6p equals 36. Aha, p equals minus 6. Let's check that in the second equation. The second equation was 15q plus 9p equals minus 84. So that's going to be 15q, so that's 15 times minus 2, so that's minus 30, plus 9p equals minus 84, so that would give us 9p is adding 30 to both sides, minus 54, so p would be minus 6, oh good, just like it was before. So I found p and q. P is minus 6 and Q is minus 2. Now let's just have a look and see what the question said. Oh, find the value of P and the value of Q. So I've done that. I thought perhaps it was going to ask me to find the area of the triangle or something. Okay, and that is the end of that question. All right. Okay, now that is the last question that I'm going to include today in today's live, but I hope you found the session useful. The next time that I am on live, because I'm away for the weekend, is on Sunday evening. And if you want to take part on Sunday evening, then that is when I will run through a past paper, which I'm going to compile out of past IGCSE questions on the topics which we reckon are going to come up for you on Monday morning. But that is on Sunday evening. And if you want details of that, then there is a film on the channel to tell you about that. I think it's called something like Are You Free on Sunday Evening? So I'm sure you'll find that film. And I think I'm ending there. So thank you very much for coming. I hope you found it useful. And if you know anybody else who's taking their IGCSE who would find this film useful, you'll find the film on the channel once I've knocked off the first 10 minutes. So it'll be there for you to share if you'd like to. Right. Okay. So it just remains for me to hit end stream and to say thank you for coming and good luck on Monday. Let me know how it goes.